Okay, this is telling us what quadrant we are in. And that helps us decide on what our signs should be for all of our trig functions. So we could actually we only have to find 4 trig functions because we're already given one, which means we can get the second one. So if the cotangent of theta, or x, is 3 over 4, then we know that the tangent is 4 over 3, right? And we are in what quadrant? Jacob, what quadrant is that? From pi to 3 pi over 2? 3. We are in quadrant 3, so we need to think about what we know about quadrant 3 and what the signs are. Tangent, we know, is positive along with cotangent, and that means all of these are negative. For me personally, I like to put those signs in there right away so that I do not forget to deal with those, because it's very easy to forget to deal with your positive and negative signs. So for me, I like to deal with that from the get-go. All right, I need you to think about what we're given, and I need you to think about what we are trying to get to. So we are given cotangent, and along with that cotangent, that means we also really know about tangent. And we have to figure out what sine and cosine and secant and cosecant are, right? So probably the easiest way is, let's think about whose identity has a cotangent in it. Nick's or Mikey's or Larry's? Larry's identity. So Larry, what does your identity say?
1 plus cotangent squared x equals cosecant squared.
Okay, so 1 plus cotangent squared x equals secant squared x. So we're going to plug in what we are given. We're given what cotangent is equal to, so we're going to plug into that spot. And we're going to be able to figure out what secant is. And then from there, that means we can get our cosine, right? Okay, so we're plugging into this identity, this numerical value. So this means we are plugging in 1 plus 3/4 squared. Guys, notice no x's. It's just numbers here on that side, right? And that's equal to secant squared x. So we square 3, we get 9. We square 4, we get 16. I think I want to rewrite that 1 as 16 over 16. That might make things a little bit easier. Right? So if secant squared of x is equal to 9 plus 16. Ooh, thank you. Man, Mrs. Ireland. Get with it. Thank you. Whew. Wow. That's bad. Thank you very much, Larry. All right, 1 plus cotangent squared is cosecant squared. Cosecant squared. Cosecant squared. Cosecant squared. 9 plus 16, we get 25 over 16. So now we get that the cosecant of x, here's the deal at this point. Here's why writing in those signs already is helpful. Because at this point, we're taking the square root of both sides in order to solve, right? So we should consider the positive and the negative. Well, we already know what the sign needs to be because we've already taken care of that. So we know it's going to have to be negative because we're in quadrant 3, and cosecant values in quadrant 3 are negative. So if you want to write it over here, that's fine. Just make sure in your final answer you've got that negative in there, right? Okay, so the square root of 25 gives us 5. The square root of 16 gives us 4. Okay. Well, yeah, no, we added that together there, right? We're adding 16 plus 9 to get the 25.
Yeah, 16, okay.
Yep. Okay. So cosecant of x is negative 5 over 4. And yeah, this is a pretty nice triple here that we've seen before. So you might know what the answer is going to have to be, but we got to do the math to kind of think through this. Okay, we have a few options here now. We have to figure out our cosine value or our secant value. So let's think about whose identity would we use if we were thinking cosines? Is that Nick's or Larry's or Mikey's? Nick's. So we could use Nick's identity, sine squared x plus cosine squared x equals 1, and we could figure out what cosine is, and then find its reciprocal. If we wanted to try to find the secant, that would be Mikey's identity, right? And Mikey's identity has to do with tangent, which we know that value also, because if we know cotangent, we know tangent. So, should we use Nick's identity or Mikey's? Mikey's. Okay, let's use Mikey's. Okay, so Mikey's identity says, let me get this written correctly this time, 1 plus tangent squared x is equal to secant squared x, right? Does that sound right, Mikey?
Yeah.
He's still having to check. Nick, are you still having to look?
No.
Good answer. So what's your identity?
Sine squared x plus cosine squared x equals 1.
Beautiful. Okay. Larry, do you have yours?
1 plus cotangent squared x equals cosecant squared x.
And no peeking?
Nothing.
Okay. The pressure's on.
This is easy.
The pressure's on, Mikey. All right, 1 plus tangent squared x equals secant squared x. What's our tangent value? We already figured that out because we flipped our cotangent. So 4/3. So we're doing 1 plus 4/3 squared, and that's equal to secant squared x. I want to square that 4/3, so that gives me 16/9. And here's where we need our common denominator, right? So I'm going to rewrite that 1 as 9/9.
What happened to the 1?
9/9? You okay with that?
Yeah.
Okay, so 9 plus 16, so we get 25/9 equals secant squared x. So secant x, technically, we should be considering the positive and the negative, but we know we're in quadrant 3, and we've already written those signs, so we kind of don't have to worry about that. We know square root of 25 is 5, square root of 9 is 3, and we already decided it should be negative. So secant of theta is 5/3. Cosine of theta is negative 3/5. Somebody in an earlier class asked me, why can't we just do triangles? Because we're practicing with these Pythagorean identities, and you'll see and understand later why we are doing this so that you understand how to do this process. So just trust me on it. If you want to use the triangles to check your answer, I'm totally fine with that.
Why is it negative?
Because we're in quadrant 3, and sine and cosine values in quadrant 3 are negative. Yes? Okay. Okay. Questions? Let's try this next one. That one was pretty straightforward. Yes, that was just one question. This is new, so it's going to take a little bit longer. Once you get a little bit more comfortable with it, it won't take as long. But you got to practice with it first a little bit. Okay, we're going to do the same thing, so I'm going to write this out first. So sine, cosine, tangent, cosecant, secant, cotangent. All right, let's decide on positive and negative signs and label what we have. Tangent of theta is negative 1/2, so cotangent would be negative 2. All right, we are being told, man, this is nice. I'm telling you quadrants instead of you having to figure it out. Okay, what quadrant are we in? Peyton, what quadrant is this?
2.
2, yes, excellent. So in quadrant 2, we know that tangent's negative. And what about the other signs, Peyton?
Cosine and secant are negative,
Good.
and then sine and the other one are positive.
Cosecant are positive. Awesome, yes. Okay. Similar to what we did on this last one, I'm seeing tangent. Let's just go with it. So Mikey, what does your identity say?
1 plus tangent squared x equals secant squared x.
And you didn't look this time. You've got it. Yay, good. Okay, so 1 plus tangent squared x equals secant squared x. Let's plug in what the value that we have. So 1 plus, in this case, negative a half, and we're squaring that, and that's equal to secant squared x. So squaring that negative 1/2, we get 1/4. I want to rewrite that. Let's rewrite that 1 as 4/4. So we have our common denominator, right? So 5/4 is equal to secant squared x. So then we take the square root of both sides. We should be considering positive or negative, but if it's a secant and we're in quadrant 2, we already know the sign. Maybom, what do we get here when we take the square root?
5/2, or
Okay, root 5/2, and we're in quadrant 2, so it'll be negative. So negative root 5/2. And if we flip that, we gotta rationalize that, right? So negative 2 root 5/5.
Isn't it?
What?
Yeah.
Oh, I switched them, didn't I? I'm sorry. Thank you, that's what you guys were saying. I was like, what are you saying? What are you saying? Okay, man. All right, Ireland, I'm all kinds of goofy mistakes today. Good, I'm keeping you on your toes and you're keeping me on my toes. Thank you, appreciate that. Now my pen's acting up. Okay, so secant is negative root 5/2. So that means our cosine is negative 2 root 5/5. Okay, I do want to do one of these with the sine squared, with Nick's identity, the sine squared x plus cosine squared x equals 1. So let's do this one. Yeah, definitely. With that value, that's a pretty one. You need to kind of see how you're going to square something like that. Okay, so sine squared x plus cosine squared x equals 1, and our cosine, so we're going to keep this as sine squared x plus, okay, negative 2 root 5/5, and we're squaring that, equals, I'm going to write that as 25/25 instead of 1, because we're about to have to find common denominator. Wouldn't that just be what, sweetie?
Well, because it was cosine, it's actually for cosine, and the reciprocal of that is secant. So
Right.
Can we just go back to where it was already squared with the 5/4 and just flip that 4/5?
Oh, well, yeah, I see what you're saying. Yep, I see what you're saying. Yes. I want you to see how, if you have a number like this, but yes, that's a great observation there. Good pickup. All right, if you square that negative 2, you get 4 times that square root of 5 squared, you get 5, and then over the 25. So we're going to have sine squared x plus 20/25 is equal to 25/25. So sine squared x equals 5/25. So when we take the square root, we're going to have square root of 5/5. And then if we flip that, right, if we have 5/5 and we have to rationalize, we get 5√5/5. So we just get a root 5 there. Yes? No? Kind of? Maybe? What do you think? Not too bad? All right, I'm trying to look at this next one to decide whether, man, I need some better examples, because all of them are starting with cotangents and tangents, and I'm not liking that. All right, I'm trying to decide if we're gonna look at example 3 or that practice problem next, because we're only gonna do one of them. Okay, let's look at example 3. First thing to decide, notice we are only looking for sine and cosine on this one. And you are not being told specifically which quadrant you're in, you have to decide. So think about what this is saying. This is saying cotangent is positive. JR, where is cotangent positive?
1 and 3.
There you go, good, you got it. And this is saying that cosine is negative. Larry, where is cosine negative? 2 and 3. And so we are talking about quadrant 3. And in quadrant 3, Larry, what are the, Jacob, what are the signs gonna be for sine and cosine in quadrant 3?
Negative.
Both negative, excellent. So sine and cosine are both negative. So I'm still dealing with that first, just to take care of that. All right, so here I need you to think about the fact that we're not gonna just go with whatever. We've got to kind of specifically get to either a sine or a cosine. Now we can go in a roundabout kind of way by using secant or cosecant. So, but we kind of need to decide what kind of trail do we want to follow down to get to these answers, if that makes sense. So we're given a cotangent. Do we want to use the Pythagorean identity that has to do with cotangent, or do we want to flip that and use the one for tangent? What do you think? You've got to decide. For me personally, I prefer to go with what I have right here, just because I'm less likely to make a mistake, although today I seem to be making quite a few. But for what it's worth, so let's go with the 1 plus cotangent squared theta is equal to cosecant squared theta. We're going to figure out what cosecant is, and then we're going to flip it. Right? Okay, so 1 plus 2 squared, so 4, is equal to cosecant squared theta. So cosecant squared theta equals 5. So cosecant of theta equals the square root of 5. And we're going to have to flip that for our sine. So we have 1 over the square root of 5, which gives us negative root 5 over 5. Okay, now we have another choice. We're trying to get the cosine, and we're given a cotangent. We could use our sine value that we came up with. Not as preferable as going back and using what you're given, but it's an option. Where should we go from here? How do we want to get to that cosine value? Do we want to use our sine value, or do we want to use Mikey's identity that has a tangent in it to get to the secant and then flip it? What do you think? Somebody make a decision for me. Mikey. Go Mikey. Okay, so we're using Mikey's identity. So 1 plus tangent squared theta, thanks Trevin, equals secant squared theta. So 1 plus 1/2 squared equals secant squared theta. I'm going to rewrite this 1 as 4 over 4. And we've already decided on our sign, so our secant of theta is root 5 over 2, so Cosine, when we rationalize that, is gonna be 2 root 5 over 5, and that's gonna be negative because of the quadrants we're in. Yes, there's some work involved, right? Okay. You have a delta math